Now that we have multiple EC2 instances hosting our application in private subnets, it's time to distribute our request across our servers using the Elastic Load Balancing, or ELB service. Conceptually, how this would work is a typical request for the application would start from the browser of the client and is then sent to the load balancer. From there, the load balancer determines which EC2 instance to send the request to. After it sends the request, the return traffic would go back through the load balancer and back to the client browser, meaning your load balancer is directly in the path of traffic. Now, if we're looking at the architecture, the ELB looks like one thing. It looks like a single point of failure. But ELB is actually, by design, a highly available and automatically scalable service, much like S3 is. What that means is that A, the ELB is a regional service, so you don't have to worry about maintaining nodes in each availability zone or having to configure high availability yourself. AWS maintains that for you. And B, the ELB is designed to handle additional throughput and will automatically scale up to handle the traffic coming in without you having to configure that feature. Now, there are several types of load balancers that you can choose. There's the application load balancer. That load balances HTTP and HTTPS traffic. There's the network load balancer that routes TCP, UDP, and TLS traffic. And there's the gateway load balancer that is mainly used to load balance requests to third-party applications. For our employee directory application, we'll be load balancing web traffic, so we'll be using the application load balancer, or the ALB. When you create an ALB, you'll need to configure three main components. The first component is a listener. The goal of the listener is to check for requests. To define a listener, a port must be provided as well as the protocol. For example, since we're routing web traffic and we set our application to use port 80, we'd want our load balancer to listen to port 80 using the HTTP protocol. Additionally, we could set up a listener port for 443 using the HTTPS protocol. The second component is a target group. A target is the type of backend you want to direct traffic to, such as an EC2 instance, AWS Lambda functions, or IP addresses. A target group is simply just a group of these backend resources. Each target group needs to have a health check, which is how the load balancer can check that the target is healthy so that it can start accepting traffic. The ALB operates on the application layer, which is layer 7 of the OSI model. This gives the load balancer a lot of cool features, and one of those is the third component, which is a rule. A rule defines how your requests are routed to your targets. Each listener has a default rule, and you can optionally define additional rules. So if we had two target groups, A and B, we can set up an additional rule that says if traffic is coming to our /info page, we can deliver that traffic to target group B. So because of the fact ALB operates on layer 7, you can customize paths for your traffic. Okay, now it's time to put this in practice. Let's create an application load balancer in the console. If you want to find the ELB service, you'll need to go to the EC2 console. So we'll type in EC2 to the service search bar, and then on the side panel, we'll select load balancers. Once we bring up our load balancers dashboard that shows all of the load balancers for this region, we'll then click Create Load Balancer. Here's where we choose which type of ELB we want, and you see the three main types. We'll be using the ALB. From here, we'll choose a name and call it app-ELB. The next setting asks if we want an internet-facing or an internal-facing load balancer. An internet-facing load balancer does what you might expect, which is route requests from clients over the internet to your backend servers, or targets. An internal load balancer, on the other hand, will route requests from clients with a private IP to targets with a private IP. For example, if you had a 3-tier application with a web, app, and database tier, you could use an internal-facing load balancer to route traffic from your web tier to your app tier. For this app, we'll be routing internet traffic, so you can leave it as internet-facing. After that, we choose which availability zones we want to route traffic to. First, we'll choose the VPC, select both availability zones, and then choose the two public subnets. Now you choose your security group for your load balancer. This is where you decide which traffic you want to allow in. Here, we'll choose a security group that will allow traffic on port 80 from anywhere. Then, we configure the listeners and routing. Currently, the default setting is to allow HTTP traffic on port 80. If we want to allow or limit to HTTPS traffic, we can click Add Listener and choose HTTPS, but for this demo, we'll stick with the default. Next, we'll configure routing, and for this, we need to click on Create a Target Group. This will open a new page where we can configure the target group. First, we will select the target type, which will be instances. Then we can scroll down and we'll give it a name, such as app-target-group, and leave all of the defaults selected. Then we'll click Next to choose which instances we want to live in the target group. For here, I'll choose the two instances I've created in private subnets and click Include as Pending below. And click Create Target Group. Now, coming back to the load balancer creation page, if we refresh the dropdown for target groups, we'll see the target group that was just created. We will select this and then scroll down, accepting the rest of the defaults and clicking on Create Load Balancer. After the load balancer has been created, we can then select it and find the DNS URL in the description box. We can then pull that DNS URL, copy and paste it into a new tab, and from here, you can see our app. If I go to the /info page of our app, you can see which availability zone we're currently in. If I refresh the page a few times, you should see eventually that I'm being directed to both my EC2 instances in both AZs.